what we're actually going to be doing today is we're going to be covering how to choose the proper toolpath. Now, we're going to go across a wide spectrum of different options because every toolpath is specific to what it can do. You know, some toolpaths are just pocketing styles where they pocket in and out. Other ones have options where you can do a trichoidal type of cut or a planar style cut. So we're going to kind of just go across a few things and kind of just cover the bases of how you can pick the proper toolpath. I wouldn't say it's always picking the right one, but it's also just opening your guys' eyes to the options that the toolpaths actually offer. So what we're going to do first is go through the PowerPoint, and then we'll continue on from there. So obviously, my name's Cody. I've been doing the webinars for a good few years and everything. I'm one of the technical advisors here, just helping. You know, I do a lot of demos during the day, and I occasionally help out here with support and training. But webinars are kind of my baby, and I kind of handle it in the aspect I need to. In this webinar, we'll identify ways you can save time. Obviously, by saving time, that's saving you guys money. And picking the proper operation is going to help you get the job done either faster or more efficient, so you're not using as much tooling or wasting as much time actually programming. Now, what we're actually going to do in this particular case is the topics we're going to cover is curved surfaces, large area roughing, also, you know, small area roughing as well, just kind of showing you what the different roughing options do and how they can actually benefit. Pocketing, we'll cover some of the chamfer and fillet options as well as complex 3D surfaces. If throughout this thing you guys have any questions, please just start typing away at the questions. We'll be able to cover them on the subjects we're actually going over. So just a few examples of some curved surfaces. You know, obviously, curved surfaces could mean multiple different things, but I usually just signify it with either a variable surface or a regular curved. Large area roughing, we're probably going to use a lot of this part here, in particular the one that's actually used in this model. It just covers a wide variety of aspects for us, and it's pretty nice for us to be able to actually use because it can show a lot of different things. Just some pocketing stuff, you know, just kind of showing the different pocketing options and what they do. Chamfers and fillets, complex 3D surfaces. Okay. Now, obviously, the other side I always like to cover in the webinar are our training seminars that are coming up. Also, the options that we do have for you guys to get more training on aspects you guys need. We have online training, on-site, in-house here in Florida. Obviously, the weekly seminars in a different location in the U.S. And then we also, my favorite, though, is obviously those online trainings because they're personalized towards you. You can actually send your parts in, and our trainers can specifically train you on those. Upcoming, we have Rockford, Lansing, Cleveland. Cleveland's actually right before we will be at IMTS. If you guys are going to IMTS, definitely swing by the booth and say hi. And then we have Baltimore and Scranton. And then obviously we have our support options for you guys. A few of the nice support options are obviously telephone support, being able to contact our support team and actually ask questions when needed, and to go over a few things as well. Okay, so we have our part open, okay? And the first thing we're going to cover, like I said, is going to be the 3D roughing options. Okay, there's two of them in particular that you can use. So we're going to just do the job setup. We're going to pick milling, just a basic 3-axis machine. We're going to pick our actual solid model. Then we'll go ahead and pick our stock. We're just going to do a rectangular block. Now, what's interesting with this, the two toolpaths we're going to use Z-level rough, and we're actually going to use advanced rough. Okay. What's nice about both of them is they both rough 3D. Okay, so you don't have to just do a regular roughing. You can use it on 2D if you have a solid. You can, but in particular, they're really good for 3D. So the first thing we're going to cover on them, if we go ahead here and we right-click on Machine Setup and we go down to our Mill 3-axis, what's going to actually happen is I'm going to select Geometry. I'm going to pick it, right-click OK. And then what I'm going to do is I'm going to hit Next, because we want to rough away the excess material that was around it. So we have that rectangular block around the model. And in this particular case, yes, the block is the exact size of the model. It's already pre-cut. That way we don't have to worry about that. We're going to choose a wrap plane and feed plane, and then the strategy, okay? So Z-level rough, and then there's advanced rough, okay? Now, if you look at these photos pretty closely just from there, as you can see, the Z-level rough stops on the edge. So these are center cutting tool paths. So they go down the center of the tool. So it's still going to wipe out the wall. But when you turn on advanced rough, it actually cuts past it. It's doing a different style cut for the corners. So we're going to go over what the differences are. So we're going to do Z-level rough, and then we're going to add an advanced rough and hit next, okay? So in Z-level rough, you can go through and you pick your tooling. You pick your patterns, pocket in, pocket out are your cutting pattern options. Then you have climb mill or conventional mill. On the parameters page, you're actually going to have the option to choose depth of cut and step over, okay? Then you have your XYZ allowance if you're leaving material on the model to come in with the finishing pass afterwards. Now, we go down here to our leads, plunge, ramp, or spiral, and then we'll go down here to our actual options for us to go ahead and see the rest of it, okay? So what we're going to do is on there you have this option called innermost only or outermost only. What that allows us to do is say we pick a part that has multiple pockets in it. We can actually go ahead and say, okay, well, what we want is we want to only do the innermost. So you do innermost and it only cuts the inner. Outermost, you only do the outermost, okay? You also have options for by area or by level. So by area means it'll go ahead and cut one area, then go to the next. By level means it cuts level to level if there's multiple pockets, okay? Now, after that, we go down here to advanced rough. Okay, so you're going to see a few options that are definitely different, and then we're going to see the toolpath output, and then we'll cover what's different about them. So you pick your tool, we're going to do the same exact tool, and we're going to actually do the same exact settings. But if you notice, right off the bat, there are an extra option. There's two different types of options, actually. So you have offset, which is kind of like zig or zigzag on the previous one. You have parallel cutting, and you have advanced or adaptive roughing. What adaptive roughing does is it actually will go ahead and actually create tricordial moves, and we'll go over all those selections as well. But right now we're going to make it match the previous one just to see what the output is between those two. Parameters, we're going to do the same depth of cut, same step over. And then in the leads, you have plunge, ramp, a few options that are different in here, as well as you can see, there's multiple more options for the ramping, as well as say you want to come in from the side. You want to start with the side of the tool, so you want to plunge off the part and then come in with the side of the tool. If you undo this checkbox, it allows you to do that. Whereas the previous Z-level rough will actually only plunge into the part or ramp into it. Now, the other options, this toolpath in particular has a rest machining ability. What the actual rest machining ability actually does is it actually allows you guys to go in and check the rest machining, and you can have another advanced rough right after it, and it'll come in and go to the areas that the previous tool couldn't fit. Now, if I go ahead and I hit compute, let's see what they both look like. Okay, so let's go ahead, blank them out, and that way we can see them individually. So if we click on a Z-level rough, as you can see, it's doing what we need it to. It's roughing out the model. Now, as you can see, in areas where there's corners like this over here in the bottom corner right here, that we're actually looking at in the left, you actually notice that it's not cutting exactly past it, so it's kind of running along the wall. Okay, it's doing the depth of cut, it's doing a good job stepping over, so there's no problems there. It's actually going to do what we need it to, right? So take a look at that, picture what that looks like, right? Keep it in your mind, and then look at what advanced rough did. Now, as you can see, it kind of spread itself out a little bit more. It's actually going through and cutting past the wall. So instead of just going right along the wall and just cutting along, it's actually going past it, okay? Now, the nice part behind that is I'm not actually cutting along that wall. I can go a little bit past it, okay? So I can actually go ahead and cut the way I want to. Now, the other nice side is, say, you don't want to cut it this way. You want to cut it in a planar style cut. What you can do is you can actually right-click on Machine Setup. You are able to go down here, and you're actually able to say, okay, in the actual toolpath, we're actually able to go down here and say Patterns, and we can say Planar. What that's going to do is that's going to allow us, after we choose our planar option, to go ahead and actually take a look at what the planar is doing. Okay? So this is what it looks like doing a planar, where it's actually doing a straight across cut, back and forth. Okay? So options like that can actually change the way you want to machine. Now, the last big option, the reason why I'm heavily favoring the advanced rough right now, is because it has those extra options. Those extra options that can help me speed up my production. Down here, all right. Now, what we're going to do down here is we're actually going to change it to adaptive roughing, okay? Just so you guys can see that output. And if you turn on zigzag, we won't actually have as much rapids that we do. Those pink lines that you see on those toolpaths are actually the rapid moves when it's traversing up to go to another option or another area, stuff like that. That is your rapids. So the adaptive rough will take your toolpath a little bit longer. Now, the nice part about that adaptive rough is that it's also available in 2D Pocket. What's nice about it is it does the tricordial style. So instead of it just engaging and going down the center in a straight line, it's actually taking swipes at the part, okay? What's nice about it taking the actual swipes is it actually can go faster, and you can take a smaller step over bigger depth of cut and actually do it faster, okay? Also helps with your guys' tool wear. All right. Now, let's take a look at what these things do in simulation. So let's go ahead and post yes, no on this one. We're going to do the Z-level rough simulation. Hit run. So notice too, I mean, it probably looks a little laggy on your guys', obviously due to the internet connection, and it looks like it's jumping around. It does run smooth, but what it's doing is it's just doing a different style rough. Speed it up. I'm going to speed it up for us so we're not sitting here. We're going to just see how it looks on the material. So there we go right there. Okay. As you can see, we got areas where there's still material, big steps, right? So we can go back in, exit out of there for a second. We're going to go ahead, do a post yes, no on the first one, and we are going to go ahead and actually undo the advanced rough. And let's go take a look at what that one looks like in the simulator as well. Now this one in particular starts with circling the outer edges, going around and around and around, coming in, and then it's working on the inside with that adaptive. Obviously, if it was just a straight on cut as well, you would still be getting the same style of cut. All right. Speed it up. Now another thing you'll notice, right? Right off the bat, the one thing I want to point out is on the previous rough pass, on these corners here, where my cursor, I'm going to zoom right in on it for us. Okay. The tool left a radius mark where it came in, but it couldn't go all the way across. So it actually, there's still a bigger chunk of material here on the advanced, or on the regular Z-level rough. But in advanced, it actually cuts across. So when it comes down to roughing, you should always try to use the advanced rough for the extra options. It's not saying that Z-level rough is not a good toolpath, because it's great when you're just doing simple pockets and everything. In this case, we have an open model. It's not just a pocket. So it actually gives us more of an option to actually achieve faster programming, faster machining, the ability to have our part come out properly right before we go into maybe our semi-finish and then our actual finish itself. Any questions before we continue on roughing of advanced and Z-level rough? All right, go ahead, and if you do have a question, just type it away as we're going. I'm going to go ahead and move on to the next one. So now we have the rough done, okay? And what we're going to do is we're going to use the advanced. We're going to go ahead and add in some curved options, okay? So if I go down here to Mill 3, I hit Select Geometry. I'm going to pick my model, right-click OK. Then I'm going to go ahead and I'm going to hit Next. What's going to happen is I have my option for rapid plane, feed plane, okay? Next two we're going to cover. As you can tell over here as well, you have a lot more options for surfacing. You have equidistant, pencil, advanced planar, project curves, advanced Z-level finish, okay? What we're going to do is we're actually going to use advanced Z-level finish, or Z-level finish, and then we're also going to add equidistant, okay? Actually, no, we're going to use advanced Z-level finish, sorry. Okay. So advanced versus regular, okay? So the reason why there's two of the same type of toolpath is we actually went in and changed a few things, okay? So regular advanced, we want to use a ball mill, right? So we tell it a ball, okay? As you can see here, one style of pattern, climber conventional, depth of cut. You have, again, your XYZ allowance, and then you have your leads. Once you guys go ahead and that, you'll go down here to your actual roughing for this one, and we're going to say, okay, for the advanced level finish, we'll use the same ball. Pattern page, again, we can choose start from top, go to bottom, zig, zigzag, or spiral. Okay, we're just going to do zig for right now, just like the other one. Parameter side, you're going to have your depth of cut, but you also have extra options, which we'll cover in a second as well. Adaptive depth cut, machine flats, and then you have XYZ allowance on the bottom, and then you're going to have your leads, where you guys can go ahead and choose plunge, ramp, or spiral, and the same lead options. The big difference is when you click on options for Z-level finish, you have all, inner, outer, which is what we had for that Z-level rough. Well, you guys go down here and you guys can actually choose in this. You can say, let's cut if we have a boundary. Maybe in advance we want to cut past the boundary. You guys can tell it to cut past the boundary. You also have an angle range option, which is pretty interesting, where you guys can actually define a specific range of an angle. It'll only calculate on the model that on the parts that actually fall between that range that you put for the angle. So if I go ahead and I hit next and I hit compute, let's see what we get on the finishing passes. All right, so let's go ahead, blank out the two, like so. So here's the level finish, right? Now, it's doing a pretty good job. Problem, first off the bat, bigger scallops up top, right? It's a projection of a toolpath going down on the surface. It is cutting everything. So let's go ahead and boundary it off to only touch the top. So if we go to the boundary option, reselect, and we pick the boundary, hit OK, and then we recalculate that toolpath, and we'll leave the other one without it at first, okay? There you go. Now, if you notice, see these extra non-needed moves that it's going over and cutting, because that's the boundary. That's what it does, right? Well, if we go down to advanced level finish, you notice it's actually not cutting everywhere without the boundary, right? So now, if I go ahead, and as you guys can see, still fanned out options on top, and that's just because it's a projection of that toolpath. If we go ahead and blank this, or compute this one with the boundary on the actual top part, there we go, okay. Give me 1 second. All right, Sorry guys, I'm trying to calculate this real quick, get all this sorted out. Good. All right, it's calculating away right now. There you go. So now it's doing the same thing that the previous one did. So now it's only cutting on that top surface. Okay, we did choose zig. That's why there's so many rapid moves, because it's cutting one direction and moving over and cutting the next one and moving over and cutting the next one, right? In a scenario like this, we want to be able to actually go in, but maybe we want the same step over. Maybe we want to keep a nice scallop, uniform scallop across the whole part, no matter what the variation and change of the actual toolpath is. Well, there's a toolpath for that. And that particular toolpath is equidistant. Okay? It is the only toolpath that actually will generate the same scallop across the model, okay, besides the rest of the pro options, like planar, stuff like that, across the model, okay? Advanced Z-level finish and Z-level finish are more designed to cut the walls, right? Not to cut the peaks in the top of the part, right? Well, watch what happens when we go in. We choose our step over for equidistant, okay? And we'll compute that one because those ones are already computed. Watch how this toolpath looks in particular. All right. It always takes a second longer with the equidistant because of the amount. This toolpath is a surface-based one that's really nice because it actually processes. A lot of toolpaths that you run into 3D-wise will do a projection down on the part. Equidistant actually goes. If you look, you don't see any areas, if you actually go in here, because this is actually the model, where the scallop changes besides these walls. Well, we don't even want it to go down in there. So we'll go ahead and boundary this one off as well. Take top surface right there for this one and recalculate that one. And this is going more into your curved surface style cuts where you guys need to go in. So picking the proper toolpath is very critical because as you guys saw with like a Z-level rough and the advanced Z-level finish, you've got a lot of rapid moves that aren't needed, a lot of traversing back and forth that isn't needed. Well, with equidistant, what it's going to do for you guys, and this again comes down to picking that proper toolpath, is it's going to start and it's just going to start moving around the model. Not lifting up. It's just going to keep moving over. So just so you guys can actually see what that one looks like, I'm going to post yes, no the other two, because we already kind of know what that one's going to do. It's going to wrap it around. It's not doing what we need it to for this particular part. We want a nice, smooth transition. So we'll go here, go down to the simulation, and let's take a look at what the rough and the finish will do together. So we can skip the first op by hitting next op. What that's going to do is that's going to eliminate us having to watch the rough again. We can go right into our finish toolpath. Go ahead. Obviously, those steps are still a little too big, but that's fine for this example. You guys can obviously adjust yours. But if you look, it's just going to go around, and it's just going to keep going, following the pattern, going around, not doing useless, unneeded moves. So that alone is going to cut down with the amount of rapids you have to do from part to part. You could do zigzag, but again, it's still going to make unnecessary moves as opposed to just machining that surface, which is what that toolpath is designed to do. Now, the other thing I'm going to point out too, guys, the standard 3-axis and the Pro 3-axis, the standard is for entry-level 3D. If you're doing mainly just pockets profiles and you're drilling some holes and then you get that occasional 3-axis surface, those toolpaths, you can do everything you need to, and you're going to be able to go in and machine your 3D surfaces and get everything done and get the jobs out the door and get everything situated. The Pro is more for the people that are using more 3D surfacing. That's not saying that people that aren't can't get the Pro. They have a lot more options and they can help with the machining process. But if you're doing consecutive 3D surfacing and 3-axis roughing and everything like that, you're going to want those options that are going to help you speed up and get that part off the machine faster and get the next one loaded up. So if you are doing more advanced 3D surfacing and you're doing a lot of 3D roughing and everything, you should definitely have the Pro side. if you're just getting into 3D, you should always start out with the standard side so you get the hang of everything, and then you can always add the pro side as well. And that way you get the more options, and that way you actually will, you know, in a way appreciate them more because you've already machined these parts, you got them done, but then you go in and you're like, holy cow, now I got this part that's coming in that needs 3D surfacing like an equidistant toolpath. I'm going to have to get the pro. And then you get the pro and you're like, okay, that's making my life easy. Okay, so as you guys can see, that's all that toolpath does, is it just goes around and around and around and around. Now, on to the next. So that's covered our 3D surfacing, just a few of the options. Obviously, there's a lot more options, toolpaths in there, and if you want more info on that, we can sure provide you guys with more info on what those toolpaths are used for. We're just picking a few right now in this webinar just to cover some things to kind of give you guys a good starting point to start messing with some 3D toolpaths. Now, another option you run into, okay, and I'm just going to quickly make the part for us, is what do you do when you have a actual fillet or a chamfer? Okay, well, let's go ahead and start with the actual portion first. So we'll put a quarter radius around there. So I have this option here. Now, let's say you actually have the ability to have a corner rounding tool and you just want to run a corner round around it. You have a toolpath for that. Okay, so what you're able to actually do is you can go into the CAM side, right? Okay, with the actual 2-axis, you select your profile, so you would select the bottom or the top, it doesn't matter. Constant Z around it. You go down into the actual strategy, and there is a chamfer option for a chamfer toolpath. What it does, it calculates profile based on your chamfer parameters that you put in there. And then you also have corner rounding. Okay. So what we're going to do is we're going to go ahead and choose the actual corner rounding, add it over. We'll get rid of chamfer mill for this example. And all you're going to do with the chamfer or a corner rounding tool is you obviously type in the radius, and then you guys can choose your pattern. You know, this is a typical 2-axis profile. It's just actually going to output the actual corner radius. You guys are able to go in here, choose your parameters, single step, multiple step, and then of course you guys will have your lead-in options as well. Now the nice part is, once you have that defined and you guys hit compute, sometimes with this profile you guys might run into this on the inside. You guys just need to flip your actual default chain start point, reverse the direction, recompute your toolpath, and it'll actually showcase it on the outside of the model. That's one way, right? All right, we actually have a question here, and it's, can you use planing to do the same thing versus the chamfer? Are you talking about using the planar toolpath, or are you talking about using just a regular like 3-axis toolpath stepping down? Okay, so the question is, do you guys, okay, obviously when you run into a chamfer scenario, right, and we'll go ahead and cover this. What we're going to do is we're going to change this solid model to a chamfer. So we're going to edit it really quick, change it to a chamfer. It's going to make it a chamfer, right? So you would use the same profiling option, just the chamfer option. What is the question is, can you use planar to do the same thing? Yes. If you don't have a chamfer tool or you don't have a corner rounding tool, you can use the 3-axis surfacing options to go ahead and achieve that option. And that's what we were going to cover next. So when you go down here and you choose mill 3-axis, what you do is you just select those surfaces that you want to run across, okay? Now, particular scenario you're going to run into. If the chamfer is only on one side and you're cutting across, that's fine. You can use a planar. But if it's something like this where it's actually around a whole entire shape, you're going to want to use like equidistant to get it. Because what's going to happen, and I'll show you guys both, if we go ahead and we choose equidistant offset, and we choose planar. Okay. Planar is designed to cut one direction. So what it has to do is if you're cutting this way, it's going to cut this like this across, unless you do 4 planars each going the way, which you totally can. So what I'm going to do is I'm going to go here to equidistant. We're going to use the ball mill. That's fine. Let's do a 1/4 ball end mill. We're going to go down here and make our step over small. And then we'll do the same for the planar. And what's going to happen is our step over again is going to be small. Okay. So what you run into, all right, and you guys will see in a second. All right, let's go ahead and blank this out and this out. Okay. So planar, as you can see, cuts across, right? It's cutting unnecessary area because that's what it's designed to do. It's designed to go in one direction across, and you'll still get the chamfer. You're just going to have some wasted area. Now you can go in and try to boundary it off, but what will happen is it'll stop. It'll just keep cutting like this, staying here. But look at what equidistant does. Equidistant just follows the shape around, okay? And if you want to constrict it a little bit more, again, you can throw those boundaries on there, and you're going to achieve a different result. But if you have a radius or a chamfer, and you don't have a tool to cut it, use a 3D, use a ball, and have it step down. And especially with a radius. I mean, that's one of the hardest things. You guys can go ahead and use equidistant, and what it's going to do is it's going to step around. Just so you guys can see, let's change it back to a fillet. And we're going to say constant fillet, and we're going to hit OK. And then we can go like this, update the geometry, and then recompute it. And you'll get the same thing. Goes around, cuts the radius. Planar, still cuts the radius, just goes over it. Now, notice that when we change it to a radius, what is it not doing? It's not going far enough down, okay? What you can actually do to adjust that, and this is actually a neat little trick, is in there, there's an option in the Options tab on equidistant to do extends. So you have extends, part bottom, 3D extends, top of vertical walls, bottom of vertical walls, okay? So if I choose, let's just say, let's start with 3D extends, see what it does. Because one of the options will actually achieve what we're looking for. Boom. Now, that toolpath that wasn't going all the way down that radius is now cutting fully down that radius. So as you guys can see, with toolpaths, and you don't have to necessarily use a specific 3D toolpath only on 3D parts. You can also use them on a pocket, a chamfer, a fillet. It's just giving you guys those options to use other toolpaths that might save you guys some time by going into that 3D option, even if it's just a solid model of a 2D pocket, and using one of the 3-axis roughing options. Okay? Now, the last thing that we're going to cover is just simple pocketing. Just a couple of the different options in 2D pocket. Now, if you go into the actual piece, and let's just say we'll use this part here, and what we're going to do is we're going to change it. Now, as you guys can tell, I keep changing this single solid model. If you haven't used the solid model CAD tree and you're drawing in BobCAD, you need to, because I can go in, delete out features, manipulate features, okay? And it just makes life a little bit easier. So I'm going to go ahead, I'm just going to shell out this model to give us a pocket inside, and there we go, okay? And then what we'll do is we'll just blank out all these toolpaths. Okay. So we have a pocket, right? We want to go ahead and cut this pocket. So what we're going to do is we're going to go down here, we're going to turn on mill 2 axis, we're going to hit select geometry, and we're going to pick the pocket. Hit OK. Hit next. That's fine with the depths. We're not too worried about that. We want to make sure we are on pocket. We'll get rid of the profile finish for now. You guys go down in here, and what's nice is you tell it what your tool is. You go down here. You have zigzag pocket, offset in, offset out, which is your typical offset in, offset out, and advanced. So what we're going to do is we're going to go ahead and we are going to choose pocket out, start from the center. We're going to do a single depth and hit compute. So it tries to cut the rectangle, right? Obviously in the corners it's not because it's a radius tool. There's that, right? Okay. Now, I want something different though. I don't want to just keep cutting the shape. I want more of like a radius move, stuff like that. I want to follow. I want to have some sort of radius in there. When you go into edit and you guys go into those patterns, that advanced pocket option you turn on not only cuts open pockets as it indicates with the actual image. So if you guys are trying to do open pockets and you didn't know, the advanced pocket does open pockets. So what you need is a dotted line, solid lines. The dotted line is the open area, and it will cut past it, okay? But it has that adaptive roughing option like we did with the actual 3-axis advanced rough. Take a look at it. So look at that. So it starts from the center, and then when it gets to the corners, it radiuses in the corner, and it keeps shrinking the size of the radius to get up in the corners. I like that a lot more than that jerky move of just like square cutting the pocket. So know that you don't have to, and if you don't have a machine, because a lot of people use this for high-speed machining, you can still use it. You're just going to be cutting slower, but you're going to still be able to get the spiral out and in the corners. Now, that's covering your 2D pocket options, right? Obviously, with pocket, there's a lot more options with zigzag and everything. So zigzag is just a back and forth, okay? Hopefully, this is giving you guys some more insight into go in and play with some of those toolpaths. Go in and actually see what the output is, because sometimes you're going to be able to find something that's actually going to work better, maybe for your particulars of what you guys do. If you do specialty parts, you might find a toolpath that saves you more time. But actually use those different options. I mean, it's always easier to cut with a bigger tool and then have a tool come in with a smaller diameter and go into the areas that the previous tool couldn't fit. That alone is going to save you time. So start looking at these toolpaths as, okay, just because they're categorized as 2, 3, doesn't mean I have to only use it for 3. I can use it for 2, okay? So go into those, start playing with those. If you guys have more questions or you want to find out more of what all the other toolpaths do, because obviously with Pro, there are more options in those toolpaths with spiraling and stuff like that, please let us know, because we can actually give you guys more of that info. The whole idea of this webinar was to try to just give you guys some insight on picking those right toolpaths to try to help with the type of machine you guys are doing with 3-axis surfacing or just 2-axis pocketing. So I really appreciate you guys coming in. We will get this recording out probably within the next couple of days. And if you guys did attend last week's webinar, we are working on getting that recording done for you guys as well, so you guys have more recordings. We are working on some ideas. If you do have ideas for a webinar to see, please shoot those over, because we are trying to find different things to do. We're somewhat running out of some of the ideas because we've been covering such a wide spectrum of stuff. So please let us know. We like your guys' input. And like I said, if you guys have any questions or anything like that, shoot it over. We'll try to get you the answer quickly and point you guys in the right direction. Again, I appreciate you guys showing up for the webinar. Until next time.